Hey everybody, Mr. Mills here. This is Precalc video for section P-3. It's about solving equations, so I'm just giving you a heads up beforehand. We're going to solve lots of equations by hand because we want to be able to do those processes. We're also going to be able to use these handy dandy little graphing calculators. So you got to get really, really good with these things. I'm going to try and show you some stuff that way too. We're going to solve linear equations today. We're going to solve some quadratic equations. And again, the basics is you have to be able to do PEMDAs backwards when you're solving regular ones, and you have to be able to factor when you're solving quadratic ones. So hopefully your factoring skills are pretty good. If not, you can go back and look at some of the videos that I have from Data A or algebra class, or just go online and Google factoring and how to be able to do that pretty well. So here we go. This is a look at solving equations for section P-3. So the first one, and again, you can copy any and all of these ones down, is 2x squared plus 7x minus 15 equals 0. Well, I'm just going to give you a quick little rundown of this. So if I do a quick sketch over here, and I want you to understand this more and more and more, 2x squared plus 7x minus 15, if it's got a y-intercept of minus 15, that means there's something that touches right down here. And then it's got a positive 2x squared there. So the parabola's either got to go like this or go like this, where the vertex is going to be either one of those sides of that thing. But regardless, it's going to touch twice if it's this way, or it's going to touch twice if it's this way based on the y-intercept there. You know it has to open up positive because this is a positive 2. Okay? So we could graph and we could find the solutions. I'm going to show you that in a second. But we could also factor. We know that with any quadratic, that's one of our first go-tos. So I know that this has to be 2x and an x. Factors of 15 are 1 and 15 and 3 and 5. And I know that they need to differ by 7. I know it's a difference because this is minus. And the only way you can get a minus 15 is if one's positive and one's negative. If they were both positive, that would be a positive 15. If they were both negative, that would be a positive 15. So I know I have to have one of each. So I can see that this difference is 13, and this difference right here is 2. And you're like, neither one of those works, so it doesn't work. However, one of these numbers is being multiplied by 2. So which of these numbers could I multiply by 2 and then have a difference of 7? And I'm hoping that's obvious then. If I multiply that 5 by 2, that would give me 10, and the difference between 10 and 3 is 7. So I'm going to put the 5 right there, and I know I need this to be positive 7. So the plus goes there, and the minus goes there. And I already used the 5, so 3 has to be the thing that's left. And now you can see I have 2x minus 3 times x plus 5. And if you multiplied those two things back together again, you would get the original 2x squared plus 7x minus 15. Now, if we know that this thing equals 0, the only way two things can multiply together to equal 0 is if one of them is 0. So this one's pretty obvious. X would be negative 5. And this one maybe is a little bit harder. You always take the opposite of whatever's here, right? So that's a negative 5. But I technically divide it by what's in front of that x, and that's a 1. So negative 5 divided by 1 is still negative 5. So here we go. The opposite of negative 3 is 3. 3 divided by 2 is 1.5. Okay? So those are my two solutions. X equals 1.5 and x equals negative 5. And now I'm going to spend a few minutes on this graphing calculator, and hopefully this is going to help for a lot of stuff for you guys. Okay, so the first thing I'm going to do is I'm going to go ahead and turn this on. And I'm going to brighten up that window just a smidge so that you can see that. Hopefully, blow this up a little bit and zoom in and focus. Look at that. That looks, should be awesome for you. So the first thing I'm going to do is I'm going to go to my y equals. Y equals. I'm going to clear out any old equations, and I'm going to go up here to the top, and I'm going to hit enter so that none of my plots are lighted up, because I don't want that to be an issue with my graph. I'm going to go ahead and put in my equation, 2x squared plus 7x minus 15. Hit enter, and then go ahead and hit zoom 6. That's your standard viewing window, and you can see that Looks a lot like the picture that I drew on the paper just a few minutes ago. Okay, so I can see that it touches twice, and if I look closely, -1, -2, -3, -4, -5, that's one of the solutions that I said was right. And then 1 and 2, and it's right between 1 and 2, so that's 1.5. I can double check it by simply going, let's let the second equation equal 0. Then I hit graph, and you can see there's my parabola, and there's where 0 is. I'm going to go ahead and do second trace, number 5 intersection, enter, enter, enter. And you can see one of my solutions right there is 1.5, which is what we got when we factored. And second trace, number 5. If I'm going to do enter, enter, enter again, I have to move my cursor closer to this other point. So just get it over there closer to the other intersection point. 3 enters. And you can see the other one was -5. Awesome. So that's our first way to be able to check. Second, and again, anybody who's had me for data class knows that every time we solve an equation, we know that we want to be able to do this. I want to be able to take my answer, -5, and store it in X. And just to make sure you're clear with this, the store button is right here above the on key, STO. We'll use that a ton in this class. And the X is right here below the mode key, X, T, theta, and N. X, T, theta, and N right there. Every time that we want to use a storage, I'm going to go ahead and put it in there. So then I hit enter. So that's supposed to be one of my solutions. So now I can type in my original answer, 2x squared plus 7x minus 15. And when I do that and I hit enter, ta-da, it should equal 0. Well, 1.5 is also supposed to work. So I'm going to go ahead and do that. 1.5 store in X. Make sure you hit enter to store it. And then I'm simply going to type in 2x squared plus 7x minus 15 again. It should have replaced the -5 with a 1.5, and I hit enter, and you can see that it's 0. Now, it doesn't mean that everything equals 0. Just to be clear, if I was to just make up something like 4 and store it in X, enter, and then I'm going to show you this. On the newer calculators, you can just do this. You can just scroll up and hit enter, and it'll pull something from above. And you can see that 4 actually gives me 45. The two solutions, the only two solutions, are the ones that we saw from before. Okay? So, again, if you guys need extra videos, understanding on how to use this graphing calculator, I've got lots of stuff on my website. Please go there and watch some of them. Okay. Here we go. So what do I have left here? We got a lot left, and I'm not going to use, I'm not going to do it every single time on the calculator, but I'm going to go here next. So this is a square root function, and a square root function, of course, looks like this, right? That's a typical normal one. And it's been altered, so it's a little skinnier, it's been shifted a little bit, and it's been shifted down. So it's going to look something like this. And we want to know where it equals 2. Well, 2 is right up here. So the big issue here is that it's only going to equal it once. So our goal is to find out that one solution. Okay? So we're going to do it with our algebra first. So I want to be able to get rid of this square root, but I can't do that with this -5 on this side. So again, PEMDAS backwards. Please excuse my dear Aunt Sally, backwards. So I'm going to add 5. I'm going to add 5 so that I can isolate this radical. So now I get the square root of 2x plus 7 equals 7. I square both sides, and I get 2x plus 7 equals 49. Subtract 7, 2x equals 42, and divide by 2, and I get x equals 21. And you can see that it must have been a long ways down there. 5, 10, 15, 20, 21, yay! That would be the solution. But again, this was just a quick thing, a quick sketch out. These don't grow very fast. They grow pretty slow, so we had to go a ways out there. But how do I know that that works? Well, let's go ahead and put it into our handy-dandy calculator again. 21, store it in X, hit enter. There you go, focus that again so you guys can see that. And then simply type in your original problem. So second square root, 2x plus 7 and right arrow over, and it says -5. And when I do that, make sure the -5 is not underneath the radical, and you hit enter, and you're going to hope that it says 2. Perfect, because that's what the equation said it was supposed to be. So I know that it worked, and I can move on to my next problem. You can also graph that if you want to. Pause the video right now, go ahead and graph that and find that intersection, and you'll find that the intersection actually is 21. Just make sure that your window goes far enough to the right. Okay, so let's go to some linear ones and work a little bit more on the PEMDAS stuff as it is. So in order to be able to solve something like this, where you have x's on both sides of the equation, you need to get rid of all the parentheses first. So get rid of all the parentheses first so that everything is even. So I got 3x plus 5 equals 4x minus 8 plus 7. And then combine like terms. So 3x plus 5 equals 4x minus 8 plus 7 is -1. Don't have your mistake be there. Don't make that a +1 or something like that. Make sure you do it all the way through. So move the smaller x always to the bigger x's side. So I'm going to -3x. Now +1 minus 3x, and then +1, and you'll see 4x minus 3x is x equals, and then over here 5 and 1 is 6, x equals 6. Yay! And I can plug it back in again just by hand. 3 times 6 is 18, 18 plus 5 is 23. Over here 6 minus 4 is 4, 4 times 4 is 16, plus 7 is 23. Check mark, check mark. That works. Let me show you a quick little thing on your calculator too, so you can do this. I'm going to go to y equals, and I'm going to graph the left side in y1, 3x plus 5, 3x plus 5, and the right side in y2, 4 parentheses x minus 2, close parentheses, plus 7. Enter and graph. Yay! There's one line. There's the other line. And you can see that they're going to intersect someplace up there. And here's the cool thing. As long as it's vertically between my screen, I don't even have to see it in order to be able to get that answer. Second trace, number 5 intersection, enter, enter, enter. You can see that it shows me that that solution is at 6. The same thing I got when I did my algebra. Okay, so algebraically or graphically, we should be rock stars at this point. Okay, how about one of these things? What happens when I got fractions? Ooh, I got a whole bunch of stuff. Well, my first rule when I have one of these things is to get rid of denominators. So make sure you write that down. We want to get rid of denominators. And you can see that I can get rid of all these denominators by multiplying everything in this equation by 4. Okay, when I do this by 4, this, oops, sorry, not to the power of 4. So I'm going to times it by 4, times it by 4. And I go 4 to this first fraction. And this 2 is going to kill half that 4 because it's dividing it. So I'll have 2 left, which will give me 6x plus 12, plus, and then this 4 to this one. The 4 downstairs is going to kill the 4 that I just multiplied in to the top, right? Technically, all these things, right, are being multiplied by 4s when I do this. Again, not 4th powers, multiplying by 4s. Well, this 4 kills this 4, and I have x minus 7 equals, and then this 9 halves, this 4 divided by 2 is 2, so 2 times 9 is 18. So that's what I'm left with next. Something looks just like that after I've distributed the 4 to each one of those. Now I'm going to combine like terms, 6x and x. They're on the same side of the equal sign, so they can just go together. I don't need to move them across. And then 12 and negative 7 is minus 5 equals 18. Add 5, 7x equals 23. Divide by 7, and x equals 23 sevenths. Or if you wanna reduce it, goes in there. What, 3 full times 3 and 2 sevenths? Either way, I'm okay. I like it. Again, you can go ahead and solve this graphically too. You could even change that to a decimal if you wanted to do that. Just changing 2 sevenths to a decimal makes us lose some of this stuff. So just be careful with that. Okay. Because I don't want the video to go on forever, I'm going to kind of say, hey, good job moving along on these ones. So, ooh, look, this is an inequality. So we want to know where this thing right here, which technically is a line, right, is less than this line right here. So let me do you a quick little rundown here, a quick little sketch of this thing. This is 2x minus 3, so 1, 2, 3, right? Slope is 2, so that looks like that. This is 4x plus 8, 1, 2, 3, 4, 5, 6, 7, 8, right? 4x plus 8, and its slope is 4, 1, 2, 3, 4. And it's a little steeper, right? So where is it less? Where is this line? Where is this line less than this line? Well, it's less than it for all of this range, right? It's below it. You can see it's below it. So it's less than it from all that range. In some place it hits. So what we're pretty much going to say is it's less than it from this point all the way to the right. So that's kind of what my answer is going to be. So I'm assuming I'm going to get a negative out of this thing, but let's do the math. So I'm going to treat the inequality like an equality until I need to do something different. So I'm going to move the 2x over here. So I get 2x, right? Subtract 2x, subtract 2x. So 4x minus 2x is 2x. Subtract the 8 to the other side. So I got minus 11. And now if I read from the x, I got to read from the x. 2x is greater than or equal to negative 11. Divide by 2. Divide by 2. And x is greater than or equal to negative 5.5, which you can see is kind of like my thing. We said that it's going to be that way over, so logically this thing matched up with my answer. X is greater than or equal to negative 5.5. Remember again that if you have to divide or multiply across an inequality, again, multiplying or dividing across an inequality with a negative number, you have to flip the inequality. Okay? One more time. If you multiply or divide across an inequality, you have to flip the inequality. So if it's less than, move it to greater than. If it's greater than, move it to less than. Okay, so let's do one of these ones here. When I have this, this is called a compound inequality. So negative 3 is less than 4x plus 5 over 2 is less than or equal to 18. I'm going to do both. I'm going to do both independently. So negative 3 is less than 4x plus 5 over 2. And 4x plus 5 over 2 is less than or equal to 18. And I'm going to solve both of these separately. So here, I multiply by 2 and I get negative 6 is less than 4x plus 5. I subtract 5 from the other side and I get negative 11 is less than 4x. And then I divide by 4 and divide by 4. And technically I get that, what does that go in? 2.75 times? Negative 2.75 is less than x. Now over here, I multiply by 2, and I get 36, so I get 4x plus 5 is less than or equal to 36. Subtract 5, I get 4x is less than or equal to 31. Divide by 4, and I get x is less than or equal to, what is that? 4 times 7 is 28, so 7.75. So it shows that x, reading from the x, is greater than negative 2.75, and it's less than 7.75. So if I was to do this in interval notation, I'd put it like this. It's like that with a bracket, right? And if I was to do it algebraically speaking, I would have negative 2.75 is less than x is less than or equal to 7.75. And if I was to do it on the graph, negative 2.75, open circle, 7.75, closed circle, and it would go just like that. Okay? Compound inequalities. And just to be clear, compound inequalities could go like this and be solutions in between, or they could go like this, and numerically speaking, 3, and it could be like one branch here, and let's go 9.5, and another branch there. It could be everything going from that way to that way. Now if I did have a solution like this, remember this is a big if I had a solution like this, then I would have in interval notation negative infinity to 3 curve union. This is closed circle bracket 9.5 comma infinity curve, because we can't include infinities. Okay, so again, inequalities, compound inequalities could look like this, and their results would look like that if I did it. Okay, so one last thing here in P3, and hopefully, again, you practice, right? When you practice this stuff on the online homework, you gotta practice it. So let's say that I had something like this. This times this times this equals 0. Well, I could multiply all these things together. And again, you don't have to do what I'm doing, just follow along and watch. Okay, so I'm going to multiply these two together first. So 3x squared, right? Plus 12x minus 5x is plus 7x. And then 4 times negative 5 is minus 20. Awesome. And then multiply by x plus 7, like this. And now I have to do distributive properties. So x times 3x squared is 3x cubed. X times 7x is plus 7x squared. And x times negative 20 is negative 20x. Now I'm going to do the 7 to each one of these. 7 times 3x squared is 21x squared. 7 times 7x is plus 49x. And 7 times negative 20 is negative 140. And all these things equal 0. I'm going to add these up. 3x cubed plus, remember, you don't have to do this right now, just follow along with my logic, plus 28x squared plus 29x minus 140 equals 0. So that is a cubic equation with a y-intercept of negative 140, which means that it probably looks something like this, except this y-intercept is way down here. Sorry, that was a bad picture. But cubics look like this, okay? So maybe it looks like this. How's that? But still, the chances are good that there's going to be 3 solutions, and that's my goal. I'm going to find those 3 solutions. And I'm going to do this by way of a graph. And maybe the calculator. Here we go. Turn it on. Look at how pretty that is. Zoom in on that, make it clear. Go to my y equals, clear. 3x to the third. That's a little caret key above the division symbol. Hoping you know where that is, because if you made it all the way to here without knowing that, that's pretty crazy. Plus 28x squared plus 29x minus 140, and zoom 6. Oh, look at that. It almost looks like 3 vertical lines. But it does cross the 3 places that I said it might cross, right? And to get a bigger picture of this, if I wanted to, I could change my y's. Let's make this negative 100 and make the y max 100, and then you can see that's closer. Remember, my y-intercept is supposed to be negative 140, so I'm going to make this negative 200, and graph. Look at that. That's such a beautiful picture. Y equals 0. Let's find out where it equals 0. And I hit graph. So, second trace, number 5. Enter. The first one is at 1.6 repeating. So I know that x equals 1.6 repeating. Let's find one of these other ones. Second trace, number 5, intersection. Move your cursor closer to the other one. Right? Enter. And what do I get? Negative 4. Awesome. So x is equal to negative 4. And one more time. Second trace, number 5, intersection. Move your cursor closer to the other point. Enter. Looks like negative 7. X equals negative 7. Yay! So those are my 3 possible solutions. And hopefully you had a aha moment right now. I just did a lot of work that I, of course, didn't need to do because I remembered here on this thing that if something times something times something equals 0, then either that or that or that or all of them have to equal 0. So you can see that this, if I put in a -4, -4 plus 4 is 0. 0 times anything equals 0. So there's a solution right here. -7 is a solution from that one. Focus that in a little bit. In here, opposite of -5 is +5. 5 divided by 3 is 1.6. Repeating, and there are my 3 solutions that I got from the graph. So again, please don't do all this extra work right here. I'm just trying to show you that it does match up and that everything is good. Okay, so our goals for today was to be able to solve all types of equations, to be able to use our graphing calculators very successfully in order to solve them graphically, to check them by substituting them back in. And we worked on quadratics and linears and inequalities, and practice these ones on the online homework, and you're going to do amazing. Okay, we will talk to you later. Bye.